Hello everyone, this is Dr. Harun Haider from Shanghai, China. In this video, I will describe how can we calculate different indices to monitor drought in different areas, such as we can calculate here in this video about D percentage, SPI, RAI, PNPI, and other indices. If you are into data analysis or working with some climate data, this tutorial is just for you. In this tutorial, I will be using Python to calculate important precipitation indices like I already described. Some D percentage. This is important, very basic indices. However, it's important to monitor drought. So again, it's quite similar with the data I'm using from Excel files, which I showed in the previous video. Maybe I can again repeat. So my data is located in this folder, in desktop, new folder 2 and drought. So we can just change the directory of this folder, and then we can process all the Excel file located in the specific folder. So see here, my data is arranged like the first column is the years, but the next column from January till December, like indices index through 1 till 13 is the monthly data of precipitation, and I am using the data of 123 years from 1901 to 2023. It can vary, the number of years and the number of stations can vary depending upon the variability of the data in your case. However, let's see how it works. Like in the section 1, we have to use different how to set this environment and how many libraries we need to utilize. So we are using pandas for handling the data, numpy library for some calculations, and OS to manage our files. Then I point out script to the folder that holds all our Excel files, like my folder path where all the files are located. So the extension of all the files are SX, so it means it can take all the Excel files located in the specific folder by itself. In the next section, like how to prepare the data, some data preparation, like which index we need to start, like which column we need to start and which column need to end. So for the January we're using index 1, and for the December index 13. So it means that the number of starting month is January, ending month is 13. However, I again repeated this one in the in my previous video. I repeated this, that if we don't have monthly data in some specific column or maybe some specific cell, for instance, we don't have a value of April in the month of 1901, so this will not calculate the RAI for that specific year. So like the indices, drought indices might not be calculated correctly. So to handle this data is very important. So for my case, I'm just replacing all the zeros in my data with 0.01, or maybe we can use at 0.001. That's also okay. So that's also negligible, but it will not be 0. So if it's 0, then the indices will be missing. Then I divided all the data into seasons, because I'm going to calculate annual as well as seasonal indices. Also, seasons can vary depending on the location, in which location you are going to study. Like this area is in India, and in some part of Pakistan is also can consider this year like monsoon, this type of South Asia region. So for winter I'm using January and February, but in some areas it can be December, January and February, like 12 month, first month and second month. However, the pre-monsoon area months are March, April, May. Monsoon months are June, July, August and September, and the post-monsoon were October, November and December. In my area it can vary depending on your area of study. Like I'm going to consider the 12 months, then we can just utilize the sum to get the annual data. However, going down we can see there are several calculation indices, like how to calculate. Like once we have all the seasonal values, then we can calculate the 4 key indices such as D percentage, SPI, RAI and PNPI. D percent help us see how the seasonal values differ from the average, whereas SPI tells us how extreme a wet or dry period is, and RAI actually compares the rainfall anomalies to the average, and the PNPI normalize the precipitation data. So all of these are key parameters to study the drought comprehensively. So we can calculate these D percentage using the seasonal subtracting seasonal means, like seasonal data subtracting seasonal mean divided by seasonal mean multiplied by 100. So this is the D percentage value, can be calculated like this, and it has different ranges. For instance, if we are talking about, like for example, if I'm going to another code, drought risk map, so see, if the D percentage is greater than 20, it means there's no drought. But if a D percentage is between 0 to 20, then it means there's normal drought, and 0 to negative 20, mild drought. If it's in negative, it means the drought is severe. So minus 40 until minus 60 will be severe drought. So so that's why to calculate the drought severity, we need to use the D percentage value. And similarly for SPI, there are also several ranges. Maybe you could consider it from the literature. However, yeah, so next is data cleaning has been done, the percentage, everything. So the data, calculated data will be stored in the in the Excel files with the starting from precipitation indices, seasonal name. Like we can just rename we can use any other name, like precipitation indices or drought indices can be okay. So the other thing is the file name can be taken from the input files. So it will take all the Excel files available and calculate all these indices for annual and for seasonal, and also it will save it into the separate Excel files. Let's run this code. Let's see how it works. So yeah, these are calculating the Jaipur data, like saved as drought indices Jaipur datasheet.xli. Let's see. Yeah, so these are have been saved. Like if we open any data, for instance, we are going to open the first one. So see, it's annual, and then D percentage winter, and D percentage pre-monsoon, D percentage monsoon, post-monsoon, and D percentage annual. See, so this is annual data, and this is the D percentage values for each of the season and annual. Similarly, we have the other values like SPI for all these annual, post monsoon, pre monsoon, and other indices as well in the same, like RAI, the winter, and pre monsoon RAI, post monsoon RAI, and yeah, similarly we have PNPI values as well. So it's very easiest way to calculate it's all the 4 key indices using Python. If you feel this video is helpful, and it can be used for your analysis, you could use these codes for your studies. However, please don't forget to subscribe my channel and like the video if you feel it's helpful. The second thing is, if you have any further question, you could ask me in the comment box. I will feel happy to respond. And if you have if you need any help regarding these calculations or anything similar to Python or other software like R, MATLAB, I have several other videos. You could visit my YouTube channel. If you are working with climate data sets, or with some other algorithm like machine learning or something, you could visit my channel, and I will keep updating videos for in future to help to make a learning environment. I hope it will be helpful for all of you. Thank you for watching my video. Have a nice time. Bye bye.